Here, let's look at two examples of partial derivatives. The first one is fxy equals to minus 2x squared plus 3xy minus 8y squared minus 32. So here we are to derive the derivative of this function with respect to x and with respect to y. And we only do it once. That's why it's called first order derivative, and it's partial derivative. Okay, so here what we do is f partial on x. So what does this mean? F partial on x. So we're only looking at how changing x affect y, affect this function. Say it's z, affects z, right? So everything else except for x, everything other than x is considered as constant, even including y. Y is also considered as fixed, namely constant. So here in this case, the first one, minus 2x squared, its derivative is minus 2 times of 2x, because the derivative of x squared is x, right? It's 2x, okay? Then plus, in this case, it is actually 3y multiplied by x. Remember, this 3y entirely is a constant, right? So it's a linear form of x with its slope term being 3y. So its derivative is just the slope term, 3y. And then minus 8y squared, does that enter into your derivative? The answer is no, because here you consider y as constant because you only view x as the changing variable. So y squared, now in this case, is as fixed as minus 32. So the derivative of both latter terms are 0. So here it is the result of this partial derivative, which is minus 4x plus 3y. Okay, and then we tend to f partial on y. Okay, so in this case, y is the only variable. Then minus 2x squared is a fixed, and its derivative is 0, we disregard. And now plus 3 times of x times y, and here it is 3x, the entire thing, as the constant multiplier to y. So the derivative of 3xy with respect to y is 3x, minus 8 times of y squared. The derivative of y squared is 2y, and minus 32, that's a fixed term, that's a constant. The derivative of constant is 0. So the result is 3x minus 16y. So these two are the result of the first order partial derivative with respect to x and then with respect to y. So that's the answer to the first case. And then the second example, okay, it is utility equals to x squared, x1 squared, x2 to the power of 6. And here you were asked to derive marginal utility with of the first one and marginal utility of the second one. Okay, so as we are talking about marginal, it tells you derivative. And here the marginal utility of the first good, of the consumption of the first good, how many units of first good that you consume, right? So that is supposed to be written this way. And then partial u on partial x2. So this is what we do. So here, the marginal utility is basically, as we say, marginal, it's derivative. And here, since we have multiple contributing factors to your derivative, you're only studying how the change in x1 affects u, then it's a partial derivative. Okay, so here, marginal utility of 1. All right. Here it's an exponential term, right? So what we are going to do is we're going to write the exponential case on the side, the derivative of exponential case on the side. So when fx equals to k, which is a constant, multiplied by x to the power of n, right? F prime x equals to, we keep k, n, x to the power of n minus 1. So here you just need to identify what is the fixed term. So in the first one, you're taking the derivative with respect to x1, then x2 is the fixed term. So now in your eye, it is actually x2 to the power of 6 multiplied by x1 squared, and x2 to the power of 6, that's your k. That's a fixed constant multiplier. So just in case that you confuse yourself, if you are ever confused, you can do this. You can write what k is. Okay, k is x2 to the power of 6. What is n? N is the exponent of the variable term, right? So n is 2 in this case. What is the x? X, that is the changing variable. Here, you recognize x1 as the changing variable. So then the derivative, for the derivative, we just plug everything in. For k, we keep it unchanged. And n and x1 to m minus 1. Right? So it is 2 times of x2 to the power of 6 multiplied by x1 to the power of 1, and we can omit this 1. And we arrange the sequence is 2x1, x2 to the power of 6. So that's the marginal utility partialed on the first good, amount of first good consumed, and now marginal utility partialed on the second good consumed is, in that case, x1 squared is considered as the constant multiplier. N equals to 6, x equals to x2. So here, then the derivative is, we keep k, which is x1 squared, unchanged, multiplied by n by x, which is x2, to the power of n minus 1. So it is 6x1 squared multiplied by x2 to the power of 5. That's how you work out the derivatives, partial derivatives.